As the presence of autonomous vehicle on the roads moves closer to becoming a reality, concerns related to safety and reliability remain pressing. Most well known as China's largest search engine, Baidu has branched out into autonomous driving, in part because of its strength in artificial intelligence, big data, and cloud services are heavily transferable into the growing field. David is the head of product of autonomous driving at Baidu USA. He is also the founding product manager of the Apollo project, the world's #1 open autonomous driving platform. Now, please join me in welcoming David Zhou.
Hi, thank BSCF to invite me for this forum. So give me a chance to talk with you about the topic shaped experience of future mobility. Actually, I just came back from an accident. So when I'm on the road, on the way to this forum, a car hit the back of our vehicle and pushed us to the front car. So I have to send my car to the dealer and ask some team members to pick me up. So you can see my hand still shakes a little bit. So I hope my voice will not shake. How can I go to the next page? Okay, so I'm David, head of product and product architect for Baidu. So when we're talking about the experience, I think a lot of us, we know that we're familiar with some basic rules of how to design internet products. So first, you need to make it super clear about what the task and what the value you can bring to your user, and then you zoom in a little bit, carefully pick the information, and optimize the interaction that user can do with your products. Generally speaking, you don't need to pay attention to too much about the physical details behind your products. For example, users do not care whether the data is stored in the office of Bay Area or stored in the desert of Nevada. But if you come to the mobility product, it's more complex. First thing, of course, so you need to let users perform the task. You need to be function driven, and for transportation, most of the time, user travels from A to B. But the next thing, well, if we go to the interaction, it's a little bit different. For example, a good example is the ADAS system design, Advanced Driver Assistance System. So ADAS is classified as level 2 autonomous driving system, which means that you still need to keep your eyes on the road and keep your hands on the steering wheel. But you may find that very interesting. When you activate the level 2 system, and you'll find the central screen always show the real-time road condition and the vehicles, your car and the vehicles around you. So isn't it very strange? Shouldn't you focus your eye on the road? That thing seems like very distracting, not that useful, because if you see something abnormal in the screen and then you take action, normally it's too late. Right? But why we have such kind of design? Because the system wants to give you like mentally feel everything's under control and mentally feel safety. Because it will tell you, it will notify you, the vehicles can see everything around, everything's under control, help user to build up the trust to the system. So in order to design a mobility system, not only you focus yourself on the logic flows, but also you need to consider, you need to understand the user's mental, user's psychological model. And even more, if you drill down, and you'll find mobility products that's not run by yourself. It is part of the very complex system called transportation. For example, when you drive a car on the road, you don't want to cut into lanes, change lanes too frequently. It's not safe and it's not good manner. Last but not least, you still need to pay attention to a lot of physical details of the autonomous vehicles and mobility products. So after all, an internet mobile product will not physically make you feel very uncomfortable, but the vehicle, trust me, it will. Because I currently feel my neck a little bit sore. Okay, so I think we are very lucky because we're born in a very great era. Humans take millions of years to work on our feet, took thousands of years to invent wheels, and hundreds of years to develop a mobile vehicle. And now, the trends are very clear that are shaping all aspects, all dimensions of our mobility and transportation. In a few decades, a couple of decades, it will fundamentally improve our life. Shared mobility, in-car connectivity, smart transportation help the vehicles enhance the participation into transportation system and autonomous driving. We are very excited about autonomous driving because it can bring so much benefits to the society. 93% of the traffic accidents is caused by human fault. And the parking space issue in the city, the traffic congestion in the city, autonomous driving has a chance to solve all those problems dramatically. In China, currently the report shows that autonomous driving adoption in China is still in the infancy stage. But it already shows a huge potential and large space to grow. By the year 2014, the total passenger travel mileage, 66% will be done by autonomous driving. However, to develop an autonomous driving system in China is a little bit different. It's very complex, not only because the condensed traffic, mixed traffic, but also some people in China do not obey the traffic rules very much. So, some pedestrians, if they want to cross, they don't look at the traffic lights, they just get in at people and then they cross. It's true. So, because of this, the solution for autonomous driving needs a lot of local customization. For sensors and for the computing system, still you can use the global general systems. But for motion planning, you may need to customize a little bit, tune it according to the China local condition. And for map localization, such services, China already has very mature solutions. This introduced further fragmentation to the market. You may already know that China automobile market is already very fragmented. So compared to US, Japan, and Germany, where you can always list a couple of big names of all OEMs, but in China, we have hundreds of OEMs, which makes none of them, or at least seldom of them, have the ability to develop autonomous driving systems by themselves. But on the other side, back to 2017, when we started to plan Apollo, at that time we have already working for autonomous driving for a couple of years. But the more we step into this field, the more we realize that this is not just an effort of one company. If cooperation is the path to the final goal, then someone need to make the initial step. So that is Apollo. We open our complete solution for autonomous driving to try to give the boost to the industry and stop everyone compete in a very low level. Now, Apollo has already released 7 versions. The very latest version is Apollo 5.0, geofence autonomous driving, volume production. Currently, we have 24,000 of developers in our community. We have 150 partners and more than 500,000 codes, made us the world #1 autonomous driving open platform. So I have a video. Okay, never mind. The video shows several of our partners adopt Apollo, download our code, and customize themselves, and try to develop a solution for their specific business scenarios. So if you take a if we take a deeper look into Apollo, so Apollo technology architecture consists of 4 layers. The very bottom layer is the vehicle layer, because we need the by-wire system-ready vehicle to communicate with the rest of the technology framework. And above this is hardware. You can treat it as you have the eyes and brains of the autonomous vehicles. And then is the software layer. We open the full software stack for autonomous driving vehicles. Map localization tells where you are, perception, prediction tells what's around you and what's going on, and planning, motion planning, make decision and draws the trajectory, control, send the command to the bottom of the by-wire system. And the cloud service layer is where our knowledge gets accumulated. We have HD map, simulation services, and also in Apollo 5.0, one big thing is we released the data pipeline. We think data is a big thing for autonomous driving. Why we emphasize so much on data? Because autonomous driving vehicles do not evolve the same as the internet products. For internet products, you can put it online and try to fix bugs one by one, and hopefully it will convert to a perfect version. But for autonomous vehicles, it doesn't work for it. First, it's not safe, and second, if you're working on autonomous driving, if you have passed the threshold of bug fixing, then you will find that you are dealing with all the corner cases, which either either not happen or happen as a disaster. So think about how human drivers accumulated knowledge and experience. When we talk about like 10 years ago driver, we are talking about this guy, this person have seen enough road conditions and understand what's happening and know how to deal with it. Leverage the power of data, autonomous vehicles can do even stronger. Take something, for example, if the code, let's say if the code cannot correctly handle the spray water by the street cleaning vehicle, we can ask our fleet to collect the data, all kinds of data for this kind of vehicle, different angle, different time of the day, different scenarios, and then send all the data into the cloud to retrain the model, to enhance the model. So every vehicle gets updated from cloud will know how to handle this vehicle correctly. Talking about data is very easy, but really get started, get a good use of data is different. Data is very big. Even you put an autonomous vehicle on the road and even nothing happened on the straight highway, nothing interesting, it still generates 10 gigabytes of data per minute. And also data is very sensitive to the hardware. You twist the angle of the sensor a little bit, you will find that the accuracy of your models will dramatically drop. And data is also very complex. The data that autonomous vehicle collect is just the raw data. The raw data need to be labeled to be understood by the computers. Currently, because of AI and autonomous vehicles, I think the data labeling itself is becoming a profitable industry already. But the problem is, a lot of the players in the market, they just label the positive cases, the positive samples. So lack of the negative samples, the model will only tell if this kind of, if this group of point clouds look like this way, it is a pedestrian. But the model cannot tell that group of the point cloud. Even it look like a pedestrian, but still, but it is electrical, and it will not move into a road. And there are layers of data like features, scenarios, and expansions. In order to enhance our partners' capability, because they have the data, they are running their vehicles in real business scenarios, they have the data. We released our data pipeline, help the partners to collect the data and extract features, train the models, and put it back to our system. Help them to turn their own data into the capability. So as I've said, autonomous vehicles has a lot of technical challenges currently, but why we still believe autonomous vehicles will be the future? because autonomous vehicles do not work by their own. Think about like 100 years ago when the cars newly created, the cars is not safer than horse cart. Henry Ford said if I'd asked people, they are asking for a faster horse. Because car is faster, so generally, normally it's not safer. But why? Today, if you see the horse cart on the road, do you think it will be safer? Can you see can you tell the traffic lights made cross the lane lines, or do you feel safe if you see a horse cart on the highway? No, because those things happened. Those things was invented after the cars to help the cars to work better. So it tells us when the technology is about to be mature, then the infrastructure itself will adjust to adopt this new technology. Human eye and the car's sensing system has their limitation. These two pictures shows the car's sight has been blocked by some vehicles. The blind spots cause a lot of traffic accidents. In order to solve this issue, we installed the sensor on the traffic lights and leverage the V2X system. The traffic lights can scan all the motion objects around the corner, around the intersection, and broadcast to all the vehicles in the range. So it's just like a policeman with the powerful sky eye. Can help us to further reduce the traffic accidents in the corner and in intersections. The traffic lights, as I've said, traffic lights, street lamps, the turning signals, the landmarks, those things are designed for the vehicle, designed for the human eye system and worked on visual based. By adding the system with the sensor capability and with the connect them to the network, we can not only enhance the capability of one vehicle, but also have a chance to optimize the whole traffic system in the city level. We have tried to deploy our first batch to the Baoding city in China, and the data shows that the traffic congestion has reduced by 20 to 30% in the rush hours. Currently, the traffic congestion, traffic problem has caused a lot of loss, both in China and in the rest of the world. But in China, it incurs 3,000 billion of RMB lost. But the investment of the smart transportation is only 24 billion. So we believe smart transportation deserves more investment, and it have a chance to change the situation from a different angle. We've talked about autonomous vehicle and the smart city. Let's zoom in a little bit back to the vehicle itself. So what drives the user's behavior for purchasing a vehicle? We find that the China users have high appetites on the car connectivity. So it plays a very important role on users' brand selection and on the users' purchase behavior, and affects whether users are willing to pay the subscription fee for the services. And China is also pushing very hard on the 5G, but 5G itself is just a technology. The technology needs a real business scenario to use it. In 2G, you can browse the mobile web. 3G, you can play the mobile game, and 4G, you can view the online videos. But 5G, what story you are going to tell the user? What you can do for 5G? Watching the high definition video? So we believe that car connectivity will create a tremendous market chance for the new technologies. So, and Baidu has invested a lot. So we have we already have a complete in-car system, including the rear view mirror and the AR windshield and the in-car robot and the in-car computer. I have another video, but I'm not sure if you can play it. This time you can play.
在该发生时发生。
检测到您处于疲劳驾驶状态，注意行车安全。
有时候，一句话不只是一句话。
小杜，今天是什么日子？
今天是你的结婚周年纪念日。检测到你心情很好，放首你喜欢的歌。
一首歌不只是一首歌，有时候只需要哼上一遍。
小杜，你在哪儿等人吗？附近有很多好用的餐厅，推荐好评度最高的。
加油吧！
有时候不需要任何语言。
恭喜你成功了。
等你说出口。
So I'm sorry it's in Chinese, but I have the English subtitles. So I think you get a point. The technologies, the machine learning technology, logic graph, natural language understanding. We're not talking about the technologies today, but we're talking about when we combine those technology, what value we can bring to users. Understand what you've said and even what you haven't. Finally, we combine those technologies together. The autonomous vehicles, the car connectivity, the transportation, and the shared mobility service. We have deployed our first batch of robotaxi in the city of Beijing, Changsha, in city of Changsha, China, and we're expanding to different cities. So if you have a chance to visit Changsha, visit China, you can take a ride. Thank you very much.